Hello everyone, thank you for coming back to my YouTube channel. It's going to be a brief task to take you through machine learning operations, commonly known as MLOps, through a course, and as task to take you through what they are and how they're significantly going to affect my machine learning project. So the machine learning operations there is deployment and training, development and training, deployment, monitoring, scaling, and maintenance. And development and training is creating and refining models. Deployment is moving models to production seamlessly. Monitoring is tracking performance and behavior. Scaling is adapting to workload variations proactively. Then maintenance is proactively managing updates for smooth operations. How these operations are going to be important in my healthcare system, because my machine learning project is about a heart detection system. So since it's an automated data management, it ensures consistent and high quality data for model training, has CI and CD implementation, so automated model training, testing, and deployment for rapid updates, has performance monitoring, so it continuously tracks metrics to address potential issues. Then explainability and trust, providing insights into model predictions to build trust, and then version control and rollback. It's going to help in improving detection accuracy and transparency. Has unexplainable AI, explainable AI techniques such as LIME and attention mechanisms enhance trust in models by explaining predictions, aiding clinicians and potential specific interpretation for diagnosis and treatment decisions in healthcare. There is active learning. Active learning optimizes model training by prioritizing uncertain data points for expert labeling, enhancing accuracy with fewer training samples. In healthcare, this label data is often limited and costly. Active learning proves valuable in efficient model development. There is federated learning. Federated learning trains models on decentralized devices without sharing raw data to preserve individual patient privacy. Right. It also helps in enhancing system scalability and performance, whereby there is containerization, cloud deployment, and monitoring. Packaging the model dependencies and runtime environment in a container like Docker ensures consistent and portable deployment across diverse environments. Then in cloud deployment, utilizing cloud platforms such as Azure or GCP provides on-demand resources and scalable capabilities, ensuring efficient handling of fluctuating workloads. It also enables in monitoring. Continuous monitoring tracks key metrics such as model performance, resource usage, and data drift, enabling proactive issue detection and resolution. This ensures optimal system performance and timely identification of potential problems that could affect accuracy or availability continuously. I was given also a task to take you through DevOps and DataOps. DevOps emphasizes collaboration and communication between deployment and operations teams to streamline software delivery. Key principles include automation, as we've already seen before, continuous integration, continuous delivery, and infrastructure as code. Whereas DataOps applies DevOps principles to manage data throughout its life cycle, ensuring quality, availability, and reliability. Key principles include automation, version control, and data governance. There is heavy MLOps and light MLOps. Heavy MLOps involves complex infrastructure tailored for large-scale deployments with intricate governance needs. It utilizes specialized MLOps tools and platforms for comprehensive model management and monitoring. whereas light MLOps prioritizes agility and employs simpler tools for rapid experimentation and deployment. It relies on open source solutions and cloud-based services for cost effectiveness and scalability. So you're supposed to choose a right approach according to what your project size is, your team expertise, and your budget and resources. So if you're dealing with a large-scale deployment with strict regulations, heavy MLOps might be necessary, while smaller projects will need light MLOps. According to your expertise of the team, and how well you know MLOps tools, heavy MLOps might be feasible. Otherwise, light MLOps simplifies management. If you're well conversant with MLOps tools, it's better to go with heavy MLOps. But if you're starting by and you're just a beginner, it makes sense if you use light MLOps. Budget and resources. Heavy MLOps tools can be expensive, while light MLOps leverages open source options for cost efficiency. Then I'll take it through DevOps and data ops more deeply. DevOps automates building, trust testing, and deploying the model code and associated infrastructure, whereas DataOps ensures high-quality data ingestion, pre-processing, and feature engineering. DevOps ensures smooth collaboration between data scientists and engineers, and whereas DataOps implements data version control and lineage tracking for auditing and reproducibility. Then DevOps manages infrastructure provisioning and scaling based on requirements, whereas DataOps monitors data drift and quality to maintain model accuracy over time. MLOps hierarchy of needs and maturity models. There is reactive, proactive, and optimized. Models are deployed manually with limited monitoring and intervention. This level is prone to errors and downtime. That's the reactive. Then proactive, automation is introduced for tasks like deployment and testing, but monitoring remains reactive. This improves efficiency but lacks continuous improvement. Optimized automates the entire life cycle with proactive monitoring and feedback loops for improvement. Integrating needs for the heart disease detection, as I already told you before, that's what my machine learning project is about. Is data security, model explainability, performance monitoring, and regulatory compliance. Integrating data governance and anomaly detection to address data poisoning threats. That's data security. To implement the XAI techniques to interpret predictions and build trust in clinical settings. There is continuously monitor accuracy, fairness, and drift to maintain optimal performance, align with relevant healthcare data privacy regulations. So data is regulated. Strategies for data integrity and microservice. There is data poisoning. Data poisoning, we're going to deal with data validation, anomaly detection, and auditing and lineage tracking. Data drift, we're going to handle it with regular model training, drift monitoring, and active learning. Then operational microservices, we're going to do a modular design, independent scaling, and fault isolation. CI and CD, feature stores and Python project files. CI/CD is automate testing and deployment. Integrate automated testing and deployment into the pipeline. It's version control, track changes and roll back to previous versions if needed. Faster updates, deliver new model versions and fixes quickly and reliably. Feature stores, centralized management, store and manage features used by the model in a central location. Versioning and governance, ensure consistent feature usage across model versions. improved efficiency, avoid redundant feature computation, simplify model training. The key Python project files, they are data files, raw data used for training and testing, like the CSV files, like we used to train the model, the data set. Then there's a model code, the Python scripts for defining and training the model architecture. There are configuration files, settings for training, hyperparameters, and deployment environment. Evaluation scripts, code for calculating model performance metrics, and deployment scripts for packaging and deploying the model to production. Thank you for watching my video. Hope I'll see you here again.